Hi, everybody. I'm Steve Bentile, one of the program managers with the Alliance for Data Science and AI, or ADSA, as we call ourselves, and hopefully you'll call us too. I'm here to welcome you to our new-ish webinar series, Building the Future of Data Science and AI in Higher Education, Lessons from Academic Leadership at the Front Lines. So in this series, we're calling on our colleagues in the ADSA community to share their experiences building academic initiatives and programs in data science and AI. The idea here is that the people speaking here will tell you what they've been working on and maybe a little bit about what worked and what didn't work, around a certain topic. So today we're talking about data science and AI at two-year colleges with our guests. Before we get started, for those of you who are unfamiliar with ADSA, welcome. We're a community of data science and AI leaders, practitioners, and educators who believe in a just, equitable future where data science and AI are thoughtfully applied in all domains for the benefit of all. You can learn more about our events and activities at our website. And a quick reminder that this event, like all ADSA events, is governed by the code of conduct that we have. You can find linked at this QR code on the slide or at the footer of our website. And if you run into any issues related to code of conduct, feel free to submit a note to us and we'll look to resolve that issue quickly. So today, as I noted, we have two guests here to talk about data science at two-year colleges, joined by Helen Burn from Highline College and Rachel Saidi from Montgomery College. They'll each give a sort of longer introduction to themselves here in a second, and then an introduction to the data science and AI initiatives that are happening at their campus. So we'll do these two institution introductions, and then we'll jump into a conversation about data science at two-year colleges between Rachel and Helen with me moderating. And then we'll have time for questions at the end. So if you do have a question, probably best to hold on to it or drop it in the chat so that we can gather those all up at the end. So I will turn things over to Rachel Saidi, who will give us an introduction to Montgomery College.
Thank you, Steve.
And then we'll hand it over to Helen in a minute.
Okay, great, thanks. All right, so first of all, thank you very much for inviting me. I love the Builder series. I've enjoyed either watching them in person or when I can't, then I still get to the channel. So my name is Rachel Saidi. I'm from Montgomery College, which is a two-year college right outside of Washington, D.C. in Maryland. I am here to talk about our data science program. I'm faculty in the math, statistics, and data science department, which is actually soon going to change, but for now we are that. And we've had a data science program for quite a long time. It's been since 2018. We started with a certificate, and the certificate was just a sequence of 5 classes, including a stats class. And then we built that to an associate's degree. And the last thing I wanted to talk about in terms of that degree is how it's led us to articulation agreements or transfer pathways. So just some highlights about our program. So I'll talk a little bit about skills and tools, and then our most recent partnerships with non-credit side of the college for creating boot camps and workshops, which are good for students and also professional development for faculty. The visualization and communication aspect, the soft skills, some of the extracurriculars that we have, and then the research arm. So because this is a talk about both data science and AI, just like everyone else, we are considering how AI is impacting our current curriculum with data science. And so one of the things that we really meaningfully did recently is we shifted a lot of our upper level content from an upper level means 200 level for a two-year college down into the 100 level. We are moving fast and furious so that by the time they get into the 200 level, they get a lot more hands-on with machine learning and AI content. So that was a recent development. The tools and skills that we give them, we're like most organizations, we make sure that our students are capable to code in Python, RStudio. They work in GitHub for version control. They learn some SQL, and actually brand new is that we're giving them some QGIS, the mapping in the free version of ArcGIS. Some of the visualization tools are Tableau. We don't teach Power BI, but a lot of our partners want our capstone students to work in Power BI, so they learn that kind of as a second-hand learning, and then Corto. The capstone we'll be talking a lot about, but that's where our students really get to shine, and also our program gets to I guess, navigate the partnerships and help our students understand what real world projects look like in either industry, government, or business. And I'll talk more about that later. The extracurriculars, so because we only have 2 years with our students, we go all in. So we make sure that we have all sorts of experiences for our data science students. There's a data science club, an AI club. We make sure that our students are participating heavily in our DataFest for two-year colleges that I'll talk about more. And for the last 4 years, we've been doing data science speaker series presentations. And then AI, this was an adorable little logo that Claude made for me. But kind of the big idea of where is everyone going with AI? What are the ethical uses of it, not just literacy, but prompt engineering and how to and when not to use coding, building apps, research, all of that. And then the last thing I will talk about is what is most important with two-year colleges is that our program can actually transfer to a 4-year after they leave us. And so I just wanted to, I'll stop there, but we'll have a lot more conversations about a lot of those things later. So thank you for that time for introduction.
Yeah, thank you very much. It's cool to see what's going on at Montgomery College. Now I'll hand it over to Helen Burn from Highline College for an institution introduction.
Thank you. And I echo Rachel in saying thank you for inviting us. We've both been involved in a lot of stuff with data science and statistics and originally in two-year colleges, and welcome everyone. It's great to see you. My name is Helen Burn. I'm at Highline College, and a little bit about us. We are a 4-year public primarily associate degree granting college. What that means is historically we're a community college, but we now offer bachelor's of applied science degrees. We're located in Des Moines, Washington. I put a map here, so it's in South King County. We're technically a suburb of Seattle, but we don't use those words. And what's interesting about our college is because Seattle has become so unaffordable, all of our rich immigrant refugee populations, which historically have come to the greater Seattle area, are now coming down to South King County. So it's a very exciting place to teach. We offer transferred agreements, applied associates, and we have bachelor's of applied sciences. In terms of data science, we have a single course, Intro to Data Science, that I'm going to talk about in a bit. It's a course that is a partnership with the University of Washington and is blossoming into a larger state project. But we do have, not just at Highline, but across the system, courses titled like data analytics. They're either offered within the college. At my college, they show up within these bachelor's programs. We have a bachelor's of applied science in cybersecurity and business management. So that's the data courses at our college currently. I also want to talk about our state system context. And this is going to dovetail into when we talk later about how to work within the two-year context. My message here is you have to understand your state system. So here's Washington's. We have a governing board for the community colleges. We have a joint transfer council that mediates this 2-year, 4-year transfer challenge. So we call our system loosely coupled. So we have complex governance with lots of local autonomy. In Washington State, we have tenure and a strong history of shared governance with faculty-driven change. We have a direct transfer agreement. So since the 90s, since I came into the system, we've had documented transfer alignment between the 2-year, 4-year, no questions asked. You do this, we take you. You may not get into the program at the university, but you'll at least get in the door. So we have a common course number system that's used. It's not for all courses. It's for very common popular courses, usually the 100, 101 courses. And like the math series has common course numbers. So I would say we have a really nice system for talking between the 2-year and 4-year institutions, but it's complicated. And so that really is, I'll reiterate my message that you have to understand your state system in order to kind of do this curriculum change, particularly around a topic like data science. So bachelor's degrees in data science are showing up everywhere in our baccalaureate institutions. But in the Washington community colleges, again, we're technically a 4-year public, but we really consider ourselves community colleges. They're mainly showing up as data analytics courses. I'd like to also mention about math pathways. That's something that I've been really involved with. I'm going to say just a bit about myself here. So I live in a math department. I have a master's degree in mathematics and a PhD in higher education from University of Michigan. I'm also a graduate of the Evergreen State College, which is an interdisciplinary public university in Washington State. And some of you may have heard that Hampshire College just closed down, which is super sad. So it's kind of like Hampshire College, but not as prestigious. And that's where I learned most of my computer science. Like many math faculty, a lot of us were trying to decide at some point, should I be a computer science major or a math major? And for me, I think at that point, I was interested, math is the queen of the sciences. It's got to be the best thing to study. So that's why I chose a degree in math. However, I do have a lot of computer science experience, and ironically, or fortuitously, I was in college in the 90s when neural networks were being explored at Evergreen State College. And the first programming language I learned was Prolog. And we were working with neural networks. I actually ended up making an expert system on line pairing. So I say this because I think a big audience for instruction in this area is going to come from your retooling your math faculty. And that's how I got involved in this final bullet here, the proposed change that the state system is considering bringing in a common course number called Data 101, Introduction to Data Science. It's based on a partnership we started about 3 years ago with the University of Washington. It's a very complex project. I have a link here. I don't know if people are going to circulate this PowerPoint, but if you want to know about that course, and this could be a really big move to bringing data science skills into the community college system in Washington State at scale. But right now it's not. So I'll stop there and turn it back over to Steve.
Great. Thank you. That was great. It's cool. Always cool to hear what's happening at institutions and sort of thinking about how they connect to other similar institutions or differ from others. So what we'll do now is we'll jump into the conversation part of the presentation. This is largely going to be me mediating a conversation between Helen and Rachel. So the less I talk, probably the better everybody will be. So I have a set of questions that sort of prepared ahead of time that I'll start with. And then as we move towards the end of the discussion, we'll start looking at the questions that come through in the chat. So why don't I kick things off with sort of a real general one. So the first question here is, who are the student audiences for data science at your institutions and maybe more broadly kind of to your colleges across the board?
I'm going to go ahead because I like a visual. I'm a teacher at heart, so I will show the slide to say that and this will probably resonate with people, that on the one hand, a lot of attention is paid to the transfer pathways into what I like to call the big D data science, the baccalaureate programs. Now, right now, that's growing in Washington State, but it's not huge, mostly because students aren't even aware in the two-year colleges that this is a major. But all of our institutions have developed. We have had a convening, so we've talked to the baccalaureates. They're all developing big D data science programs. So we need to develop transfer pathways for that. I'll say more about that later. Then we have like the associate degree level. We have colleges like Rachel's that actually offers an associate degree in data science. In my space, it's more about AAS, applied associate degrees, and they're developing, but they're often named differently. They're called like associates in data analytics or data analytics for business, that kind of stuff. And I'm sure if we have any four-year or baccalaureate people here, you'll see the same thing. It's showing up under different names. And so this to say that, the students need advising around the space to try to figure out these different options. But then there's the audience that I am especially interested in, just given that I've spent my career in a math department where the general focus of people is on the STEM majors, where I decided probably 20 years ago that I was going to focus on the gen ed folks. Or I teach a lot, like I teach mainly statistics right now to like a nursing audience. So general data literacy, data for all. And what's driving these is, we've got these growth in the BI programs, but I want to mention something that's even like more serious that was brought to my attention by the University of Washington, that our transfer students who are dutifully taking their courses for their direct transfer agreement, so they get accepted to the university, they're showing up, but they don't have any data competencies, including people in sociology or criminal justice. It's not just STEM majors. That at the universities, a lot of programs are expecting you to be able to wrangle a fairly large data set and interact with something like a GitHub. So the expectations for data competencies at the universities are increasing, and the community college students are really being left behind. Then there's this kind of nebulous issue of the demand for data-ready, AI workforce-ready people, or AI-ready workforce. And that's real. I've heard it, but it's still a little bit vague about what really are people going to be doing in the workforce. But there's definitely this sense that our students need to be ready to work with data and AI at some level, regardless of their fields. And of course, just to be like, just like, say 30 years ago, one of the big projects that was NSF funded was math across the curriculum. We recognize that people are doing math in all these spaces that are not math classes, and they're expecting students to kind of transfer their skills. Similarly with writing across the curriculum. And now we're in a space where it's like there's kind of data science competencies expected across the curriculum, including just being a critical thinker about data. Who's the creator of this data? Where was it provided? Is there any issues, caveats with this data? So that's really what I see as the two-year college student audience. And I will turn it over to Rachel for more comment.
Yeah, thank you. Rachel, do you have thoughts? Sure.
Yeah, thank you. I'm not going to show any slides for this part, so I'm just going to talk if that's okay. So I see a lot of different people in the audience, and so it's kind of interesting that I'm going to say this because our population may be a little bit surprising to a lot of folks who are in the four-year space. So in 2018, when we first created our certificate, there was no partner four-year institutions that had anything that our program could transfer to, either course by course or not. There were no data science programs. So we kind of created something that didn't exist as an articulation path. And we advertised it primarily to working professionals who took us up on it. And so about 75% of our students were working professionals. We made the courses virtual in the evening. They could do it after work. And it was a very mature audience who mostly wanted to learn what is data science and how to upskill. And so we track around to 2026 now, and we are a whole different set of students. So in the middle, let's say somewhere between 2018 and 2026, we started welcoming lots of students from all over. Like Helen was saying, we really wanted to attract students from all disciplines to say, hey, just take a data science class, just find out if you like it. As long as you took an interest stats class, you would be welcome to join and you might find you like it. But now we've actually really pivoted. Our student body has grown to almost 200 students if you take mostly our associate's degrees and a very few certificate students. But they are early college students, so they're 18-year-olds that are both getting their high school degree and they're also getting our associate's degree, all the way up to still are working professionals and maybe even some retired community. So the vast array of, let's just talk about age as a wide group. So when you have conversations about data sets, you have a different life experience. So those are some things that come into play. There's different context of capabilities in technology and comfortable level with coding and things like that. But I would really say we have like you could really make it as a dichotomous population. We've got our younger students and more traditional students and then our older population. And it also makes staffing problems, which I'm sure a lot of you realize that that's part of one of your issues. So we have to have daytime in-person courses for our early college students, and we have to still have our virtual evening classes for our adults, and then everything in between. And so we now offer for our some 200 some odd students, something like 17 sections. And so we had the growing pains of finding faculty who could actually teach all these sections. But what that does is all of these thoughts built up kind of a question about accessibility. And that's the last piece I'll talk about with our student population. So with two-year college students, many of them, they're slightly different, but not necessarily than a four-year student, because most of them have jobs, they take care of family, siblings, grandparents, things like that. They are caretakers, and they also have a lot of extra things that are on their plates. So we tried to think about how we can be most accessible. So a lot of our data classes are hybrid. So basically you can join in person, you can join over Zoom, you can toggle whatever works best for you. A lot of students really like to, of course, to be in person. That's where they focus the most on everything, but maybe their car broke down, something like that, or they have to take care of their children. So our students have a lot of burdens, and so we really just try to make it as accessible and as safe a space for them as possible, especially in this environment. This political environment makes them, we want to make sure that we're making, we're attending to a lot of their extra needs as well. So I think that's a good place to end about who our students are.
Great, thank you. Helen, did you have any follow-up thoughts based on?
Only that the accessibility really resonated. And that's with my personal experience. I've been teaching the Data 101, which is based on the University of Washington's Computer Science 180. Let me just say something about that. Computer Science 180 at UW is their first course in their data science minor. University of Washington does not have a major. They have a minor accessible to everybody. Data science folks, data adjacent, everybody. So they gave me their course. Yay. I didn't have to do any curriculum development. And the second time through, I'm like, I got to make this hybrid where students can show up live or show up online. And actually, it works wonderfully. And so I did have to flesh out some videos. The course is project-based, 4 projects. So it's like an experimental, it's a really cool class. So it's so good to make it accessible like that because, and in fact, when you're teaching something like data science and you're often screen-based showing stuff, showing stuff people online, it's great. So you do have to be a little skilled in that, but I think a lot of us has been teaching with maybe a little bit of a remote audience. So accessibility really, I think, is a core component of our two-year college students. And I had a colleague who I think I'll remain unnamed, but I think they're here, who also mentioned the importance of using cloud-based tools for accessibility. because our students are differentially resourced. And nowadays, especially, between the Zoom plus we use Tableau and then a product called Big ML. It's a no coding intro course. And so everything's in the cloud. So we don't have to deal with a lot of local hardware, which can be a real challenge for our students. I find so many of my students in my stats classes, for instance, are really primarily using their phone to access the course material. And that obviously would not work in something like data science. So thanks for the opportunity to say a bit more about
Yeah.
making sure our courses are accessible. And we also, of course, mean ADA compliant.
Awesome. Yeah, and so I have a follow-up question here, and then maybe we'll circle back to resources. But I've been wondering about the difference in curriculum and sort of pathway for somebody who is coming into a two-year college looking to get that associate's degree and then kind of head back out to the workforce rather than people who are coming in to look for a transfer pathway to go onto a four-year college. And like, how does the curriculum differ? And what are the issues of sort of managing those two different tracks? Or is
Um,
it not an issue and it's just clunky
I
dory?
guess I can kind of answer that a little bit. I'm not exactly sure. Um, a lot of our adult students already possess a degree, either an undergraduate or graduate degree. And just funny story, some of you who know me may have heard this story, but a couple of years ago, I think it was around 2020 or something like that, when we were just building up the courses and we had a capstone, which is the final course in our sequence. A capstone course that only had 4 students in it, and all 4 of them had PhDs. So they were definitely not looking for an associate's degree. They were simply there to get as much out of, our data science courses as possible. So I think it's just more of an advising thing. So at least if I understand your question correctly, Steve, I would say if somebody comes and they want to join the data science program, and let's say they already have an undergraduate or graduate degree, we may advise them to sign up, register for the associate's degree, mostly getting data science classes, but then we'll I call it the data science plus, because they're going to get a certificate if they want, and they're going to take maybe something like what is the most important math class, which is linear algebra, which isn't a part of the certificate, but is a part of the associate's degree. Maybe they'll do some geographic mapping courses under the geography department. Maybe they'll, so I think it just depends on what we advise for those students. Some students actually still, even if they already have an undergraduate or graduate, will still try to get the associate degree because they want everything that comes into it. It just depends.
Great. Helen, any thoughts?
Only see, I'm not so familiar with this space, truthfully, because I haven't been working in what I'll call, like, dare I call it, the applied data science, applied AI, like a 2-year degree, and then you're going to go to the workforce. I don't have as much experience with that, except to know what's been going on with a couple of cases where it's what Rachel says, where you offer some flexibility, stackable credentials, working towards different degrees. Luckily, Rachel's student with the PhD could jump over to take linear algebra. That's going to be a real problem for most students that want that. And I'm going to talk about that later in terms of what we call the math pathway challenge, that some of our participants online may want to kind of enter that because there's a lot of work that needs to be done in that. Students aren't going to have access with that unless they go through a lot of them pre-college courses.
Great, thank you. So I'm going to jump to our next question here. So the question is, what are the resources and opportunities that you would recommend faculty or administrators kind of familiarize themselves with or get to know for data science and AI related programs? And specifically, what types of cloud resources have you found to be helpful and available? And maybe what are some pitfalls that you've fallen into yourselves or heard that are good to keep an ear out for?
Could you say more about the pitfalls related to?
Yeah, just sort of if you've used tools or other infrastructure for coursework, for
Mhm.
example, and run into some real troubles with certain
Okay.
tools, it'd be cool to hear what those might be.
Rachel, I saw you shaking your head. Did you want to tackle that one first?
Yeah, sure. So I'll start with what ADSA is going to love me for, the shameless plug. So the shameless plug would be one of the new resources that ADSA is offering is the Advisory Council. And maybe it's not so shameless because we're here in ADSA. So anyway, basically it's a group of experienced leaders and they're offering guidance to institutions as a free resource. So anyone in this space who has a question about developing a data science program or a data science course, oh, thank you, Stella, or anything that has to do with, questions revolving resources or how to do things, the advisory council I think is a great first stop. I will say that for two-year folks, AMATYC, the American Mathematical Association of Two-Year Colleges, is also a great resource. They have communities called ANETs, but I'll just call it the Statistics and Data Science community. And then also, if you're interested, there's DataFest for two-year colleges, which I can talk a little bit more about later, but that's a great place for if you have students who want to get started in data science, but maybe don't even have a data science program, then you can give them mentorship and give them a space where they can just jump into a deep dive into a 2-day, 48-hour essentially. It's like a hackathon where they're trying to explore big data sets and try to come up with solutions. A third one I'll talk about, and actually, if I'm really bad at talking and pulling up, so I'll pull it up afterwards, is there is a NSF grant for the two-year college data science initiative. So I'll pull that up afterwards. But basically, this summer, there is a workshop being held for two-year college faculty, and they're going to provide technical and pedagogical training for two-year college faculty who are interested in teaching data science or bringing in data science courses. So I promise I'll put more in. And then I just had one more, and that gets into kind of the good and the bad, the pitfalls. So there are AWS educator consortiums. My faculty and I are actually joining one through Howard University is setting an AWS educator consortium up for us. And so we have a good partnership with Howard University folks. Google does something similar. I can't say whether it's going to be good or bad because I haven't done it yet. I do know that they are proprietary industry leaders, so I do have my own questions about it, but I guess, to be determined later. My only pitfall I've had is that every time I've tried to do any sort of online courses for my own professional development, I have never yet once finished one entirely. Maybe I shouldn't be admitting this in a recorded space, but I know that that's true for many people because you start them with all the greatest intentions and then everything else gets in the way. But those are wonderful, and also they're still my nemesis.
Nice. What about you, Helen?
I'm going to flash up a slide that has some resources on it. All right. So a little bit of overlap with Rachel, but it's organized. So if you want to design a transfer agreement or a transfer degree and again, I struggle with data science, AI, like it's all bleeding it's not bleeding together, but there's a lot of overlap. And also not a lot of overlap. It's fluid space right now. Anyways, this is the two-year college data science initiative, and I do see one of the leaders online, as well as Rachel's been involved in that. And so I don't know if you're going to send out this slide deck, but this is kind of the big game in town right now for two-year colleges. Again, including actually even the two-year college name is confusing. Like I say, I'm in a four-year public, but I fit into this group. So the first year they spent about designing a program. And then this year, they're working on faculty professional development mainly. I'm not sure there's still time to register for this, but that's what you should be thinking about, is joining this national group if you want to do a transfer degree or offer an associate's degree in data science like Rachel does. That's the big group, NSF funded. It'll probably be around for, I would recommend it for another round of funding if I were in charge. Now, this one is really interesting. This is brand new, National Applied AI Consortium. And I went to their national conference 2 months ago. And wow, this is a new group, heavily funded, not by the NSF only. NSF is there, but also all of the tech companies. And this is about how to launch a data science AI workforce program. So if you're primarily interested in like applied AI and what they're doing, just to give you a hint, because like Miami-Dade College, check that out. They've gotten on board and have retooled their program. They're teaching students to deploy the tools. Not about, I mean, I'm not sure how much theory is in their courses, but they're deploying the tools in the context, which is kind of what the workforce needs. People that can come in and say, oh yeah, I know how to use agentic AI and I can help you. Like, so it's really applied. And it's really, I was really impressed with this. You can send faculty here. They're gonna, next year, they're at Chandler Gilbert College in Arizona. So I'd recommend that. If you're more of a researcher, like me, you might be interested in checking out the Scatterplot Journal of the MAA. They have a journal of data science. And then this is brand new. I just learned about this. It's been published. If you're interested in understanding the student experience, this master has tools to capture student attitudes in stats and data science. And then finally, as Rachel mentioned, professional development is huge for faculty. And people like me, we may live wherever, we may have these hybrid, not hybrid degrees, but interdisciplinary. I would consider myself interdisciplinary, always have been. And so data science is a perfect space for everyone. I've got an English faculty on my team at my college. I've formulated a local team, which is really super important. Should offer you that advice. Form a team on your college around this effort. You can't really do it alone. So Berkeley Data Science Education Workshops, I went to this last year. I mean, really interesting. You learn all about R, or I think they're using Python. I can't remember exactly what we learned. I've learned R, Python, kind of everything, even though I'm a strong advocate to having a no coding general education data science course. This is a repeat because the 2-year college data science does faculty professional development. Rachel mentioned these. These are all over the place and they're really good. So I'm kind of trying to inspire my colleagues to think about doing certification training, especially my part-time faculty who might be looking for full-time jobs or want to get into the data science space. Go get certified, and they're all over, and I have links. And then finally, I would be remiss if I didn't address that there's been so much attention to introductory statistics. And I would make the strong claim that 5 years ago, there was a hope that intro stats, which is our largest enrollment undergraduate math course in the country, and it has been for several years, more than calculus. The hope was that we could retool this course to have data science competencies. So that's addressed somewhat in the Gaze report. They don't address data science, but if you check out the Gaze report, they don't address it directly. You're going to see technology infused, asking questions of data, thinking about data provenance. And then originally there was an NSF grant called Stat Prep that I was involved with for many years with the hope of retooling intro stats. The reality is, if data science in the 2-year college is going to take off, the best way to do it is kind of through your math courses. And I'll stop there, but I'm going to say something about that later.
Interesting. Thank you. So I'm looking at the clock. We're at about 40 past the hour. I want to ask one more of my pre-prepared questions. and then we'll open things up to audience questions. And audience, if you have questions, just drop them in the chat. That would be great. So the last question that I'll ask maybe is AI factoring into your curriculum and programs, and how, and maybe if we have time more broadly, have you, the folks who are sort of working in the AI and data science space on your campuses, have you been tapped beyond your programs to assist the campus with this invasion of AI in higher education? So let's see, who do we want to go first? Rachel, do you want to go ahead, and then Helen?
Yeah. So I'll just say the answer is just most definitely. But I can expand on that. So as I mentioned earlier, we just completed 4 curriculum actions to change our curriculum so that our students are starting much earlier with more exposure of other things that used to be at the higher level, so that they can get to better understanding, not just what is machine learning, what are LLMs, but like, how do you use them? When do you use them? When you set up a model, it's not just about setting up a model, but there are many models, and which is the better model? How do you assess it? And, if AI tells you one thing, how do you know it's right? How do you know it's not wrong? What are the hallucinations that can happen? So we're really working hard at that. I think, like everybody else, I don't think I'm saying anything new. But where this comes into play, I think the most has been in our capstone course, because our capstone course, basically, it's the culmination of this data science curriculum, like anyone else's capstone course. But remember, we only get 2 years with our students. And so we have to fit 120 credits, 2 years, where 60 of those credits are already basically set aside for the general education courses. That leaves us with only 60 credits of data science specific courses. So we're trying to fit a lot in, because we really want our students we want to level the playing field. We want them to be ready to head off to a 4-year or maybe even a job potentially, with a lot of skills. And so, when we have our students partnering with industry partners, one of the most common questions has been, can we set up a project that asks them to use AI? Like, that has been, and we keep having to tell them, no, we're not ready yet. No, we're not ready yet. But I think we're getting closer to that point where we finally can say yes. It is an interesting question, because then, have we given them enough that they really could do it? I don't know. And that is to be determined. By the time that we send them off with all the skills, with their, predictive analytics and their modeling and their visualizations and their tools and software, then are we adding on top of that responsible AI? And I don't know that that's the answer. But I think that is kind of the big question, is how can we better prepare them from the earlier curriculum so that they can be ready for that? And I think that's where I'll stop with that point.
Great. Helen, thoughts?
Let's see, I'll echo that, AI is affecting everybody. Okay. And so have I been personally tapped to be on I volunteered myself, so I definitely am on the campus AI committees. But so is everybody else. But that may just be my college. We are, have a history of strong faculty governance, and everyone wants to get into this. To English faculty, they want to get in. Everyone's studying about LLMs. Now, in terms of in the curriculum, the intro course at the University of Washington, which we're using here, does have a machine learning section. Okay. And it's cool. It uses Big ML, which is a proprietary product. And so far, Steve, all of the commercial products we've used, Tableau, Big ML, they work pretty good. They do take a personal relationship with your IT faculty. So if you're at an institution that's not well resourced, where you can't just get someone on the phone and say, I need my students dumped into my class, that could be a problem. But the only thing I can say, which is secondhand, is most of our applied AI or applied associate's degrees, so AAS degrees, are really retooling in response to AI. And I can't quote them exactly, but the big challenge is the question of how much programming should we be teaching now? Okay. Or can we just vibe code everything? So I know, again, I'm not telling you the decision, but these are the challenges. Steve, if you don't mind, I did want to just like share this
Yeah.
one other thing that I had, and I did just put my slide deck in because there's a couple of pieces of research. So what you're talking about here, these applied associate degrees. These are some models, Sinclair College and Green River College. This is Rachel, so I put that in there so you can check out her program. But Sinclair College and Green River College are doing these like stackable credentials, fluid movement between the certificates, associates, bachelors. Someone reminded me recently that a lot of the work, not in AI, but in data science, has been around like maybe you're going to have a job is a data, like cleaning data, and that like is now changing because it can be done by AI, and that the trend overall is toward developing programs. That's that NAAIC, to teaching students to deploy tools. If you're interested in the general data literacy, non-coding, this is, there's kind of this debate out there. We should actually write a paper about this, benefits of each. I want to share that I'm going to jump up here to the Big D data science programs. We've had a convening, and the faculty in the data science programs at the baccalaureate said, go ahead, develop a gen ed coding or intro to data science course in Washington State. But when your students come to us, we want them to take our intro course, because that our intro course lays the foundation for like our whole philosophy of the program. And we feel like that's okay. But that said, this is a great article, Balmer and Horton. They tackle the state of Massachusetts about how to, some of the challenges they did when they tried to navigate a transfer program in data science, given that the community colleges don't offer all the classes they need, or vice versa. We require classes that they don't want. And then Rachel, I, and Ben Balmer and our other panelists put together a white paper or a general paper about some of the challenges with developing these data science transfer programs and general literacy. So the message is, we've got to use the guided pathways. If you want to do a transfer program or anything where your students might go on, you need to work locally. And there is a big challenge with the programming requirements and also the math pathway, because students really need, linear algebra. And then some institutions don't allow them to take linear algebra until after Calc 2. So think about fixing that. Another challenge is that there are like partial derivatives, the gradient descent problem, these kinds of things. That's like rocket science in math, but actually it's not that hard. But the math curriculum, it needs some retooling, and that is a real challenge if you look historically about all of the money that the NSF has poured into just modifying and improving student outcomes in Calculus 1, and yet the needle hasn't budged. Not to be a bummer, but there's a huge opportunity there. And then the last thing I want to point to is that, then this is a policy thing. Okay, so we just had a setback about a year ago, maybe more, in the state of California, where for a long time, data science in the high school and AP stats were allowing students to meet the admission requirements at the university. And the Board of Regents just changed that decision. So that's this BOARS. You can click on that. And so that kind of sent shockwaves, because the trend was, hey, let's start doing data science in the high school, and then they'll come in and maybe we can do data science too. And all of that kind of got goofed up because of the influence of California. Still, doesn't mean your individual state can't do it. I do believe it might happen in Washington State, but whether our Data 101 will ever become part of a new math pathway, that's going to take a lot of work. So thank you for letting me share that, Steve.
Interesting. Yeah, no, that's great. So I'll take a couple of questions here from the chat, and I'll just do these in order, or at least the order I see them. So Scott Peterson asks, how are libraries at Montgomery and Highland involved in data science education? What are other support services on campuses for data services and AI?
So I can answer just really quickly about that. We are so fortunate that one of our librarians is a data scientist, and so she She helps all our students if they're looking for resources or if they need help. She also is doing a lot of the workshops for faculty and students about how to use AI in library research and things like that. So she is kind of our go-to person. I don't know if other people have something like that, but we're really fortunate at Montgomery College.
I echo Rachel. This is our library homepage. Like, again, because of like the equity issues associated with AI, and also everyone wants to this does you don't need a degree in computer science to join the conversation around AI and data science. So we have people all over. So all these resources we're having, I think at 1 o'clock, we're actually having an AI summit that I'm going to go to. It's very, very, very active. And I would say if it's not happening on your campus, you should make it happen. And it's a big tent, right? Everyone can come in. So I'd say what other services? Just all over. And sadly, the biggest service that is being overloaded right now on every campus is the academic dishonesty officer on your campus who's having to handle issues with cheating and everyone finding their way through that. So Scott, we hope that answers your question.
Yeah. Another question here from the chat. So we talked a little bit about the sort of AI ready workforce, which is, as you noted, not easy to define and maybe left intentionally vague in some cases. Could you maybe elaborate a little bit on what the two of you think the AI ready workforce, what sort of they mean by that when it's brought up, and how you're interpreting that phrase?
I'll tackle that.
Yeah.
Okay. I think about this a lot because in a lot, okay, so again, the 2-year college students, it is like, and I guess it's like everywhere. Are you going to get these competencies from some class you took where the instructor might be AI friendly or data friendly? It's a crapshoot, and that shouldn't be there. It should be more systematic. I would hope students leaving my college would understand how to interact with AI, what are the pitfalls, and how to use it as a collaborator. That would be a very basic thing. How to use, like, not just, prompt engineering with iteration. Now, what's going to come down the pike is agentic AI. And that's going to be really interesting because I don't think our college institute, our IT offices are prepared to start having, AI interact with our Google accounts and things like that. But so right now it's basically, using it as a collaborator. That would be kind of my for all expectation. And so that you could put on your resume, a student could put on their resume. I would love it if they said, I can do basic exploratory data analysis. I can create visualizations based on data and reports. And then in the AI space, I would hope that during a job interview, and in fact, at that recent conference, NAAIC, a lot of the employers on the panel said, this is a deal breaker. If you cannot answer this question, which is, how would you use AI to help your productivity on your job? If you can't answer that question, you're going to be thrown out of the pool.
Awesome. Thank you, Rachel.
I will echo everything Helen said, and I will just say the biggest concern about all of this is that we're helping our students AI themselves out of their own future jobs. And so that's the biggest concern is, what does it mean to be AI ready workforce, but then are you also ready to also not have that job in the future? And I think that's where, a lot of the students are so nervous right now. And so maybe that's not really answering the question that was posed, but that's kind of just where my brain heads towards all of that, because it's already happened with the computer science departments. And so we want to ensure that at least if that's already happened to computer science, to some extent, maybe that we can figure out a way to prevent that for the data science students and departments.
Great, thank you. So we have just a couple of minutes left here, and I want to grab this last question in the chat before we close out. So we might need to be a little quick on this, but the question is about external credentialing and certifications for data science. And I know that you probably have your own situation on your campuses, but could you also, one of you, just very briefly touch on the accreditation situation as you understand it?
Can we clarify, because I think the question is asking about
Yeah,
like, are they getting certified, Google
yeah,
certified and Microsoft? I can't
right.
really speak to that directly, except that I've heard my computer science programs talking about that, but it's usually like an extracurricular. What I'd like to see is I'd like to see my colleagues, like, because I'm on a committee where we're trying to train the college, faculty and staff around AI to use it as a collaborative partner in their work. I'd like to see more of them taking advantage of that. But right now, I don't think it's a part of like the general curriculum. Thank you for the question, Matthew.
Yeah, I think I would say something similar to Helen. Although in our credited side, we don't have any credentialing, at least in the data science department, that may exist in computer science. But I do know that our non-credited side, the workforce development side, they have a lot of credentialing and badging and micro badging. They're a powerful group. I don't know how many other folks in this space have a lot of relationships with their non-credited side, but at least on in our school, they seem to have almost infinite funds. I don't want to say it like that, but every time I ask them, "Can you develop a boot camp about Python? Can you develop a boot camp about something?" They're like, "Sure, let's do it." And so they've been incredible. And when I was at the ADSA Leadership Summit, one of our panelists at one of the sessions was talking about at NC State where they have one credit courses that are so flexible at coming in, going out as their popularity increases and decreases. And I could see that being a place for credentialing as well. So I think depending on what your institution has the capabilities for and allows, that seems like those are different ways that you could do that.
And I want to say thank you, Rachel, for bringing up that because that fact about workforce development, it's a whole different funding source. And there's a lot of different funds over there because we need money to do these projects. So definitely people should explore that if that's available on their campus.
Yeah, perfect. All right, so we're up at about the top of the hour, and I'd like to thank Helen and Rachel for joining us today and talking a little bit about their experiences in building programs at your colleges. And if you have questions, I'm going to assume that either of them might be able to take a question by email if you have them. If you have questions about building these programs generally, I'll also point you to our advisory council, which was mentioned at the top of the hour. So ADSA has an advisory council that can help facilitate questions about data science programs. But yeah, thank you all. Thank you for being here, and a final round of applause, virtual round of applause for our speakers.
Thank you, everyone, for being here. I
Thanks
wish
so
you
much.
luck, and we're here to support.
Great. And then the last thing that I'll note just before we totally get out of here is our next Builder series is on May 7th, where we'll be talking about standing up data science institutes at universities and colleges. So less education focused and more application focused. So hopefully we'll see you there. All right. Thank you, everyone.